Hey, this is James Spann, chief meteorologist for a local television station, and guess what we're going to do today? We're going to talk about weather. I promise if you strap in, hang tight. If you're good listeners, you're going to learn a lot. We'll have some laughs, and this is going to be really good. I'm typically in a school this time of the year, but I'm not. I can't be in a school because right now school has been suspended. I'm not allowed to be in big gatherings. Nobody is. So we're just going to do this online. And let me just say this. We are really starting this off with something really cool. Does anybody know watching this what today is? This is something special in terms of the Earth and the weather. And that satellite image that was taken earlier this morning should give you a clue. This is the first day of spring. The Vernal Equinox happens tonight, 10:19 Central, 11:19 Eastern. The sun's rays today directly over the Earth's equator. Now, when we go to the summer solstice, the Earth's rays are directly over the Tropic of Cancer. The first day of winter, the winter solstice, the sun's rays are directly over the Tropic of Capricorn. But today it's the vernal equinox, and I absolutely love that. The Earth's terminator, that's that line you see dividing the daylight from the darkness. It's vertical, absolutely vertical, connecting the poles. And here's kind of a cool animation. This is 1 year and 12 seconds. And you can see because of the tilt of the Earth, we're tilted 23.5 degrees on an axis. You can see how that terminator shifts from season to season. So here's my next question for you guys. I would like to know, of the 4 seasons, which one is your favorite? Which one? Which one is your favorite? I know mine. I mean, there is no doubt in my mind. I don't have to think twice. I know. So the question is, what is your favorite season? Mine happens to be winter. Because guess what happens sometimes? Guess what happens sometimes? You know what happens sometimes. It snows. Now, where you live, it might snow a lot. Where I live, it doesn't. I'm down here in the deep south, but from time to time, it can. This is some great video from a friend called Kevin Henderson. He has a business called Skybama, and he flies drones in weather events like this. He is rocking a drone in a snowstorm. I mean, how awesome is this? But what I want to do right now, I want to show you guys something that I've not shown to hardly anybody. This is going to be some super secret video. This is what it looks like in my weather office at the TV station when it starts to snow. We have a security camera. It is recording what happens in the weather office 24 hours a day, 7 days a week. It's always recording. And I pulled some video from that security camera on a morning when it snowed. This was last year. So I want to show you guys right now. And by the way, I typically don't show private video like this, but I'm going to show it to you because I like you. This is what it looks like in my weather office when the first flake starts to fall. That's it right there. I'm not going to say which one of those two guys I am, but in any television weather office in the United States, I promise that's what it looks like when it starts to snow. Yeah. So later today, I will go into this room, and tonight, in front of hundreds of thousands of people, I will tell folks what the weather's going to do tomorrow. That's what I do. I am a meteorologist, and we're going to talk about how we forecast the weather today. We'll talk about certain types of weather today. And by the way, they pay me to stand in front of a green wall. Hey, this is great stuff. How'd you like to be paid money to stand in front of a wall? Now, you know the deal. If you watch that on TV, you never see the green, you see weather maps. This is called chroma key, and most stations use green. And that's the deal. In fact, I'll tell you a little secret here. If you were watching the pre-show, you know the deal. I'm not really in the TV studio right now. I am in front of a green wall. I'm like you. I am at my house today. You're home. I'm home. I have a green wall in my office so I can make this thing look like whatever I want to. But that's how the sausage is made. You'd learn that today. But today we're going to talk about weather. So let's go right to it. This is the first thing I'll do every day. First thing I do every single day, I will watch weather instruments and what they are telling us about the weather. We have these, of course, all over the country, all over the world. Just the basics, that camera, that's important. We need to be able to see the weather. Radar is great, and we'll talk about that later, but we have cameras. The little device up at the top, that measures wind speed. That is called an anemometer. The little black bucket, that's a rain gauge. That measures how much rain that falls. And down below that, that little white device, that's a radiation shield. It keeps the sunlight off the sensors in there. We have things like a thermometer, and you know what that is. I mean, that tells you if the air is hot or cold. We have a hygrometer. And let's talk about water for just a second, okay? Let's talk about water. If you dump a bucket of water on me, I would get wet. If I dump a bucket of water on you, you are going to get wet. Water can be a liquid. You know that. Water can be a solid. What do you call water when it's solid? Ice. But water can also be starts with a G, gas. Yeah, there's always water in the air. There's water vapor in the air, and a hygrometer measures water vapor. And so what I do, I take all this data, we put it together, and we make maps. And let me just say this. I gotta talk to you guys for just a minute. In fact, I might start to break down because I'm really sad. Do you know why I'm so sad? We're learning that most adults, grown-ups, cannot find their house on a map. Are you kidding me? I want you boys and girls to learn geography. I have always loved maps ever since I was little. In fact, when I was really little, my favorite puzzle was the puzzle where you put the states together to make the United States. I love that puzzle. In fact, I would play with it today if I had one. So we see maps all day. I see about 200 maps every day, and that's not an exaggeration, at least 200 maps a day. And this is one from about 1 hour ago. And by the way, all my maps have numbers. Numbers. What's your favorite subject in school? When I was in school, my favorite subject was math. I've always loved math. I'm not the best writer. My reading comprehension skill has never been that good, but hey, I love to work math problems. And to do what I do for a living, you better be kind of good at math, and we'll talk more about that later. But look at all the numbers on this map, and I see letters. I see H's, and I see L's. In fact, let me find one of these H's. This is one today that's way over far eastern Canada, out there around Nova Scotia, Newfoundland. And you see above the H, there's a 1037, 1037. Let me explain that big number, okay? And I'll explain what the H means, because this stuff is important to figure out how we forecast the weather. So let me ask you a question. Is there air in the room that you're in right now? Is there air in the room that you are in right now? Yes or no? Wait a minute. Somebody said no. All right. Time out. Let's do a science experiment. I want everybody to do this. Everybody breathe in. Breathe out. Let's try that one more time, because some of you didn't do it. Everybody's got to do it. Everybody breathe in. Breathe out. So here's my question. What did you breathe in? Air. So there is air in this room. If there was no air, we couldn't breathe, okay? There's air everywhere. You can't see it. By the way, things exist you don't see, like air. So what part of the air do you need for your lungs? You need oxygen. And when you exhale carbon dioxide. Air is mostly composed of a gas called nitrogen. But here's the deal. This is weird. I mean, this is really weird, but it's true. The air in the room in which you're located right now, and I don't know where you are. Maybe you're in a living room, a bedroom, a kitchen. Maybe you're in a car in a back seat, and your parents are driving. But the air wherever you are, guess what? It weighs something. It weighs a little bit. Now, you can't feel it. When you walked in that room, you weren't thinking, man, this air is so heavy, I just can't walk. No, you can't feel it, but we can measure the weight of the air with something called a barometer, okay? And that's where those really big numbers come from. In fact, let me go back to that map. It says 1037. That is coming from a barometer. That is a unit of pressure. And when the pressure gets really high, we slap a blue H on that map. And when you see a blue H on that map, you know what that means? That means air is heavy. Relatively speaking, you can't feel it, but air is heavier than the surrounding air. And guess what's going to happen when something's heavy? It's going to go where? Down. Air is sinking under those big highs, and when air sinks, it doesn't rain. It can't. The fancy science word is subsidence. When air subsides or sinks, it doesn't rain. It literally crushes the clouds away. But around these lows, guess what? The air is light, and we've got one today over the plains of Colorado, east of Denver. You see that L? That's a little east of Denver. And the winds converge, and the air is lighter, and the air is lifted. And when air is lifted, the air cools, and something happens called condensation. and it rains a lot. And so today, near that, we're going to have rain and storms. We had some pretty rough weather last night. We'll have some pretty rough weather today in advance of that. So if I could pick one instrument to use in forecasting the weather, it would be a barometer. That's a big deal. That measures the weight of the air. Now, wait a minute. Under highs, air goes down, and around lows, air goes up. Guess what that means? Air has waves, just like the ocean. Maybe some of you have been to the beach. I wouldn't mind being at the beach today. Well, water has waves in the ocean. Guess what? Air has waves. You can't see them because you can't see the air. Let me show you guys a map of the waves today. This is what the wave map looked like earlier this morning. There's a big wave out there in the western states, and that's producing a lot of unsettled weather. And I have to know where these waves are to forecast the weather. And by the way, this map shows me the weather about 18,000 feet off the ground. 18,000 feet off the ground. So here is the next question I have for you. How in the world do I know what the weather's like 18,000 feet off the ground? I mean, I'm not even 6 feet tall. I'm a little stubby guy. So how in the world do we know what the weather is like 18,000 feet off the ground? Guess what we get to do every day? We use balloons. I mean, think about this. If you're a meteorologist, if you do weather, you stand in front of a green wall or you're using balloons. I mean, this is really a great job. Now, unfortunately, I don't get to launch the balloons. I wish I could, but that's done by our friends at the National Weather Service. That is a government agency. And so what I did yesterday, I went down the road to the Shelby County Airport, which is just below the TV station, and talked to some meteorologists that work for the National Weather Service, where they launch those balloons. I talked with Kevin Laws with the National Weather Service in Birmingham. He is the SOO, the Science Operations Officer, and Gerald Satterwhite, who is a lead forecaster there.
Twice a day, we launch these weather balloons, and here's an example of a balloon here made out of a special latex. Starts out rather small, even though it looks kind of big, but this thing can expand to probably about as big as this building over here. So these things get really, really big as the pressure in the atmosphere gets less and less.
What kind of gas do you put in here?
Well, some offices use helium, but helium turns out is very expensive. So we use hydrogen here. It's a little bit flammable, remember the Hindenburg, but so certainly we want to be careful with it, but hydrogen, lighter than air, so it will rise and rise rather rapidly.
So this device is called a radiosonde, and it is the instrument package we tie to the weather balloon. And as it goes up through the atmosphere, it's measuring temperature, humidity, wind speed, wind direction, and pressure, and that gives us an idea of what the atmosphere looks like right now.
So all these instruments are in this thing, and there's got to be a radio transmitter in there too, right?
There is a radio transmitter in there, and we track it using GPS. So that radome up there, there's a big satellite dish, and we can track the signal from the radiosonde to get that important information.
What are the specific instruments in here?
So this device right here is measuring the humidity in the atmosphere. This device right here is measuring the temperature. And on the inside is a GPS device, so depending on how fast it's moving in any direction, we can calculate the wind speed and wind direction.
So what's this thing?
Well, this is a safety procedure that we have tied to the radiosonde. So once this explodes, this kicks in. This is a little parachute, so it glides back down to earth real safe and it doesn't hit your house or your car or something and injure someone or tear up something.
When do you launch these?
We do them right now twice a day. So everybody around the globe does it at 0Z and 12Z. So here locally in Alabama, that's 6 a.m. and 6 p.m. local time. And so everybody around the globe does them at the same time. So we get this good suite of consistent information all at the same time.
What altitude does this thing finally just pop?
This goes up to about 100,000 feet. So if you think about it, that's about 3 times what commercial airlines go up to. So it's almost outer space and gets pretty close.
So let's say you're walking through the woods and you find one of these things. What are you supposed to do?
If you happen to find one of these, there is a mailing bag on here, and it goes back to one of our national centers, and they can refurbish these or reuse them to help save taxpayer dollars. Now, if it's in really bad condition, we had a local school that found one and they showed it off to their school kids, so that's another option for you as well.
But you don't get most of these things back, do you?
Most of them we do not. I believe it's way less than 30% of these come back, but it does happen, especially around here when we get high pressure that sets in, the winds are really light. We had one land about 2 miles away from the office one day. Other times they're carried.
So that is too cool. So thanks to Gerald. And again, to me, that's just fascinating. These things go up about 20 miles. And on the way up, the balloon expands and expands and expands, and finally it pops, the parachute deploys, and everything floats back down to the ground. They mostly land in trees and lakes and oceans, and you really don't get a lot of them back. But if you ever find one, you can mail it back for free, recondition those things, and use them again. So one thing about weather, these guys that we just talked to, Gerald and Kevin, they work for the National Weather Service. If you want to be a weatherman one day, if you would like to do this, and a lot of kids love weather, a lot, you don't have to be on television. I do the weather on TV at night and some other things and radio, but you can work for other places like airlines. They employ weather people, the National Weather Service. I asked Kevin, what's the Weather Service and what do you guys do at your place? I think everybody knows what television people do, but what about you guys?
We provide a 8-day forecast, and we also have a consistent weather watch, 24 hours a day, 7 days a week, 365 days a year. So on Christmas morning when you're opening gifts, we're always here on the weather watch because it's so vitally important, mainly because we provide those warnings for severe thunderstorms, flash floods, and tornadoes.
For high school kids that are watching that are interested in meteorology as a career, what's some advice you can give?
Study hard in math and science.
Math, and math.
It's all about the math. If you do well in math, you will do well in this business, for
You
sure.
don't use linear equations for a fluid, do you?
Absolutely not. It's a lot of calculus and a lot of derivatives, and you'll learn about that in college, but certainly I think right now it's about required to have 4 semesters worth of calculus, and that's a lot of calculus.
So listen, and don't let the math scare you. Look, if you're in first, second, third, fourth grade, just start to learn math and learn how to solve math problems, and you're going to do just fine. If you love weather, the math is not scary at all. In fact, it really gets fun when you're older and on up through college. So thanks to Kevin and Gerald for that explanation about what they do down at the National Weather Service. So our balloons pop about 20 miles up, but guess what? I have something that goes higher than 20 miles. In fact, it's always up there. It's one of these. Does anybody know what this is? Well, the Earth is there, yeah, but what's that machine? Yeah, you know what that is. That is called a weather satellite. This is a satellite that is in geosynchronous orbit. That's a bunch of fancy words. What that means, it orbits the Earth at the same speed as the Earth spins, so you always get the same perspective every time it takes a picture. And it's basically taking a picture every 60 seconds. And you know what that means? I have your picture. I have your picture taken today. Do you want to see it? Do you want to see it? Here's a better question. Do you have your hair fixed up nicely today? Did you comb your hair nicely? I certainly worked on mine. Can you tell? I've been working on it all day. Did you have your makeup applied evenly? Yeah, paint on this barn won't help. All right, so I think enough of you said yes. So I want to show you guys your picture from today. I hope you're ready. This is you, taken about 30 minutes ago. If you saw that first satellite view I showed you, you saw how the Terminator was kind of pole to pole. It's still pole to pole, but it's moved a little bit. That's because we have daylight over much of the United States right now. And for a lot of you watching this, it's kind of cloudy. You can't really see much, but we're all down there. But come on, you can't see people. That would be really creepy. I'm not looking for people, I promise, and you can't see people from weather satellites. So what are we looking for? We are looking for clouds. Yes, we want to know where the clouds are, where they have been, and where they are going. We have multiple satellites. We have them positioned in different parts of the Earth. Let me go back about a year ago. This is an animation on a March day in 2019. You see those bubbles? By the way, I love to watch these. I could watch these all day long. You see the bubbles in that image? Those are not bubbles. Those are actually big storms that are 20, 30, 40, 50,000 feet tall. And underneath those storms, the weather wasn't good. In fact, this was a pretty rough weather day. We had a lot of wind and rain and thunder and lightning, but that is absolutely gorgeous. I love to watch weather satellite images, and there's a lot of places on the internet where you can find these pictures and see current conditions. But there's a problem. In the weather business, there is always a problem. Half of being successful in my business, it is solving problems. I hope you are good at solving problems because what we do is hard. But here's the problem with weather satellites. They show the tops of clouds. We don't live up there. In fact, if you live on top of a cloud, nothing personal, but you're kind of weird, okay? Where do we live? Underneath all those clouds. So we have to have something else to show us what goes on underneath all those clouds, and we have something to do that, and it's called radar. Guess what the radar looks like? It looks like a volleyball. You know, people drive by these things all the time, and they have no idea what that is. The next time you drive by that, I'll tell you what that is. That is weather radar. In fact, you can actually climb up that ladder and go into the radar unit and see what's up in that big ball. There is a huge parabolic dish that looks like a satellite dish, and it's on a motor. That's the pedestal, and above the pedestal, that dish sits up there, and it's really hard to get good video because it's so cramped in there, but constantly this thing is sending out little beams of electronic energy, and if raindrops happen to be out there, part of the energy will bounce off the raindrops and bounce back to the antenna. That's the way radar works. Let me ask you this. So let's say I throw a basketball against a brick wall. Really hard. I mean, I throw a basketball against a brick wall. What's it going to do? It's going to bounce back. It is going to bounce back. And that's the way radar works. But instead of a ball and a wall, little beams of electromagnetic energy that bounce off raindrops. And guess what? We make maps. Maps are important where the bounces are coming from, and my maps look just like that. Hey, man, that's Minecraft. No, it's not. I was at a school a couple of weeks ago, and some kids said, hey, man, that's Minecraft. No, this is not Minecraft. This is radar, and everybody watching this, you need to understand how this works, okay? It's not that hard. It's really easy, but I promise one day you are going to be looking at a phone and you will not understand what you're seeing. So let me explain. It's not that hard. Here's a question for you. When we use colors, it's really easy. Do you see gray, blue, and green on that map? Take a good look. Yeah, you do. Come on, that's easy. Where you see gray, blue, and green, those are weak bounces. The energy coming back is awfully weak. You know what that means? That's light rain. So if you were standing underneath the gray, the blue, or the green, it's barely raining, no big deal. Now, do you see yellow and orange? When you see yellow and orange, it starts to rain heavier. The return energy is higher. But the heaviest rain of all is red and white. In fact, when you see white on radar, most of the time it's raining so heavily, you can't even see the house across the street. So this is too cool. By looking at these colors on a map, you can see where it's raining and how heavy the rain is falling. And now with everybody having one of these fancy phones, you can see it on your phone. I mean, that is so stinking cool. When I was a kid, I could never imagine anything like what we have today. But let me go back to that radar image because sometimes other things can happen. So what do you call that really violent wind that goes round and around and around? You know what that's called. It starts with a T. It starts with a T. Yeah. It is a tornado. So there is a tornado in that storm, and here's my question. Where is it? Now, all you parents, and by the way, you parents are now homeschool teachers, you know that. All you parents, and if you're over the age of 18, you ought to know where that is without even thinking twice. And even if you're grades 1 through 5, you might have a good guess. So everybody look at that map and figure out where you think there's a tornado. All right? I'll give you a second here. I should be playing my Jeopardy music. Pick out a spot on that map. Everybody put your finger on the spot where you think there's a tornado. And by the way, if you are a professional teacher, if you teach in schools, you can't play. You know why? Teachers know everything. So the tornado, it's right there. Okay? In the back of the storm, on the left side of the screen, in the colors of yellow and orange, there is the shape of a hook. At the end of the hook, there's a little spot of red and white, and there was no heavy rain there. You know what that is? That's the radar beam bouncing off stuff lofted by the tornado, stuff that's being carried up into the air, things like tree limbs, boards, bricks, glass, nails, and that makes that spot of red and white. We call that a debris ball because that's debris carried up in the tornado from the ground. So that is a hook. And everything, every block of color you see up there, that's an echo. The radar beam bouncing off raindrops, that's a hook echo. And at the end of the hook echo, there is a debris ball. And that is the tornado. And again, if you get used to this, you can learn that. So let me go back to my basketball analogy. You throw a basketball against a wall, what's it going to do? Bounce back. But wait a minute, what if the wall is moving? If that wall is moving, it's not going to bounce back directly to you. It's going to bounce back one way or the other. Guess what raindrops are always doing? Moving. My beam comes back differently, and it's called the Doppler Shift. That's why this is called Doppler radar. And we can calculate wind, which is too cool. We can actually see wind within a storm where the radar beam is located. So let me go back and show that hook in the debris ball. Okay, that's the tornado. But let me show you what the wind looks like. Same storm, same time, okay? You see the colors of green? Those are colors that are raindrops that are coming down toward the radar. The radar is down at the bottom of the picture, way down below this storm. The orange, that's outbound. That's going the other way. And that's what a tornado looks like on radar. So we can see the tornado in the debris, and we can see the tornado in the wind. And I know for a lot of you, it looks like a bunch of spilled paint on that map. But if you take the time to get used to learning this, you can actually do this yourself. And let me just say one thing today. We're talking about science. We are talking science today, the science of weather, which is called meteorology. And here's the cool thing about this. Some of you girls watching this, and some of you boys are going to work in science when you're grown. Maybe mine. The science of weather is a funny sounding word called meteorology. But here's the great thing about science. You can take the knowledge we have accumulated over all these years and use it to help other people. That's why we're here. And if I can tell somebody a tornado's coming and give them time to go to a safe place, that is a really good thing, okay? And we'll talk more about tornadoes later. Let me show you a couple more on radar. This is a pretty big tornado, but that's the rain on the left and the wind is on the right. And you can see that little hook in the debris ball, that white spot on the left, that's the tornado. And the colors change on the right over there. Green is inbound, pink is outbound. And that's what they look like. So here's the next question. Who is this goober on television, this creeper guy? Yeah, that's me. That's what it looks like when I'm on television. And most people know me from covering tornadoes. We have a lot down here in the deep south where I am. And this was during a tornado situation. There's actually 3 tornadoes. And this is wind, okay? And if you're good, maybe you can see all 3. Now, come on. The easy one is where my hand is pointing. So we had one tornado that was near Adamsville, Alabama. I want to say this is back in 2014. The second one is the one that is below Tuscaloosa. Notice how the green and the red colors are touching tightly. And the third one is above my bald head up there that was in the northern part of the county, and that was a bad one. All 3 of those caused a lot of damage. So again, I promise if you take some time to see these examples, you can learn how to use radar, okay? But before you have a storm, you have to have a cloud. Before you have a storm, you have to have a cloud. And let me just say this. I'm hoping that many of you boys and girls know these cloud names. Every kind of cloud has a name. Everybody watching this, and I've been watching some of the comments, and everybody's sharing their name and where they're located. That is like awesome. Every kind of cloud has a name. And I have always loved clouds. In fact, I learned these cloud names in first grade. In fact, let me share my boring first grade stories. I hope somebody in the first grade is watching this. Now, when I was in first grade, my teacher was tough. She was pretty tough. In fact, I have a teacher of my first grade, or picture of my first grade teacher. You want to see it? This is my first grade teacher right here. And actually, that would be me with a Snapchat filter, but that's reasonably close. Her name was Mrs. Porterfield, and I'm really embarrassed. I'm really embarrassed because one day in first grade, I got in trouble. Uh-oh. You've never been in trouble before, have you? Thanks for your honesty and transparency. That's always best. Well, don't do this, do not do this. But one day in first grade, I was not being a good listener. And you know what that is? That is rude. Hey, teachers work hard. They really do. And if you're not being a good listener, that's not nice. And I was not being a good listener. You know what I was doing? My back was turned all the way to the teacher, and I was staring out the window. And let me tell you what. I'm the greatest window starer guy in first grade. No first grader can stare out a window better than me. I mean, I was locked into staring out that window, and I heard the voice that you never want to hear in first grade. She said, Spann, that's my last name. She called us by our last names, which was weird. Spann, get out here now. I'm thinking, oh, I'm in big trouble. You never wanted to go in the hall with her. I'm thinking my life is over at the age of 6. But as it turns out, we call it the miracle of Greenville, Alabama. This is where I used to live when I was a child. It's a smaller town in South Alabama. I didn't get in trouble, and I saw her do something I've never seen her do before. She smiled, and she gave me something from the library. So what's in a library? A book. She was tough, but she was really, really good. She noted that I stared out the window a lot, and she thought I was interested in weather. And that little book I read in first grade started me on a journey I'm still on today, learning about weather. So I want all you boys and girls to be good readers. Listen, while you're out of school, this is a great chance to read. Let me tell you what, I have no school visits. I've got some extra time. What do you think I'm doing? I'm reading. There's so much we have to learn. So just take some time and read while you're away. Come on, I learned these in first grade. These are all the cloud types. The high clouds are called cirrus. Up there at the upper right, I love cirrus clouds. They're great. They are thin, they're ice crystals, and it never, ever, ever rains from them. They make for a great sunrise or a sunset. They're awesome. Now, low clouds down there in the lower right, that's called stratus. A cloud on the ground is called what? Fog. Yeah. You want to know what it's like to be in a cloud? Next time there's a foggy morning, walk outside and guess what? You are in a cloud. That's too cool. I love foggy mornings. But my favorite are the ones down there on the left that look like little marshmallows called cumulus. And they get bigger and taller, and when it starts to rain, you call it cumulonimbus. Sky watching is just awesome. Let me tell you what, there's some great video around that shows clouds, and I could watch this stuff all day long. This is from Mike Olbinski. Mike is out in Arizona, and he does some incredible photography with clouds. And I just encourage you sometimes to look up. You know, we're so busy these days, we just forget to look up. We've all got phones and pads and pods and doodads, but you know, sometimes I just love to lie on the ground during the day and look up, and you'll see amazing things. If I'm flying in an airplane, come on, man, get the window seat. I can't believe some knuckleheads get on airplanes and they'll sit in the window seat and they'll shut the window. I said, what do you mean? That's the greatest show on earth, out the window. You're missing it. And by the way, Mike's got many, many, many more videos on his YouTube channel, which is this, also on Vimeo, and Mike's on the Twitter and the Gram and everything else. So you might want to follow him. So here's a cool thing to do. This summer, put your phone on time lapse and point it out the window. If you're in the southern United States where it's hot and muggy, this happens every summer day. Cumulus clouds growing into cumulonimbus clouds. That is an amazing machine. And again, with all these phones with a time-lapse feature, you can do this very easily, but that's just absolutely incredible. This is why I love watching clouds, and I love it when people send me pictures. You want to know something weird? I don't have a window in my weather office, and I never have. I've been doing this for 41 years. I've never had a window. How does this happen when you do weather? So when people send me weather pictures, and I'm so thankful for all of them through the social platforms, it's like my window to the world. But let's talk about cumulonimbus clouds and storms, all right? So this is a diagram of a storm, big old storm. And this is a process called what? You older kids might know it starts with a C. The process is called convection. Yeah, this is convection. Warm air rises. You see those upward arrows on the left? That's an updraft. And over there on the left, that's a downdraft. Updraft, downdraft. And by the way, the freeze line is that little dashed line in the middle where it's 32 Fahrenheit. But in the middle, it's crazy. And by the way, later, I'm going to give you a mini storm spotting session today. I need more storm spotters. But if you're looking for real trouble, you look under the updraft. I'll later show you what might happen there. But in the middle, some crazy stuff is happening. I mean, some wild and crazy stuff. You got some raindrops going up and some raindrops going down. Guess what they do? They collide. And above the freezing line, you've got ice pellets and snowflakes that are colliding. Some are in the updraft, some in the downdraft. In this constant collision business, guess what that does? It generates electrical charges. You know what's coming. Soon, you will have a discharge of electricity that looks like this. All right. Now, I got to ask you, this is a very blunt question. I would like to know your response. Are storms good or bad? Are storms good or bad? And I can almost see everybody doing this. Hey, man, they're bad. I don't like them. Storms are bad. No, 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 no. Time out. Storms are good. We can't live here without them. Let me explain why. And this might come as a shock to you. Guess what? There is no new water being made. There is no factory where they're making water today. Doesn't exist. We use the same water, over and over and over. That is called the water cycle. You know that. And a big part of the water cycle is precipitation, right? Come on, rain. And for many people, including where I live, most of our precipitation comes from thunderstorms. And if we do not have storms, guess what? We don't have enough water. Creeks can dry up. Rivers can dry up. Lakes can dry up. And we have to move away. We'd be in a desert. So listen, never, ever, ever think of storms as being bad. Storms are actually very, very good. We have to have them. So, next question. What do you call those bright flashes in this picture? What do you call those bright flashes? Come on now. You know what that is. That is lightning. And here's the deal. What is lightning anyway? It's electricity. Who says electricity is bad? If we did not have electricity, you would not be watching this video, because I'm using electricity for the computer and for the lights and for everything else in here. I mean, come on. Think of it. Electricity is great. You're watching TV, electricity, cooking food, electricity. Be thankful we have it. But guess what I am not going to do today? I'm not going to take my finger and stick it in an electrical socket. If I do that, guess what happens? I would turn into a French fry. Yeah. So this is all you need to know about storms. You don't stay outside. You go where? Inside. I promise it's not that hard. This is not rocket science. Whoa, watch that tree. See it get hit by lightning? This is why you got to go in. Let's say you go down to the beach this summer. You hear thunder. You got to go in because this might happen at any minute. And I'll be honest with you guys. I'm really afraid of only one thing when it comes to weather, and it's lightning, because every storm has it and you don't know where the next one is in. But all you do is go in a car, a truck, a house, school, church. You're fine. Hey, see if you see lightning striking in front of this car about right now. Whoa. But he's fine because he is in a car, okay? This guy's shooting out the window. See if you see lightning strike that tree about right now. And watch what happens. The top of the tree will collapse, and this is why you cannot go outside when there's lightning. And again, it's not that hard. Never, ever, ever be afraid of storms. Guess what? I know some kids, especially maybe kindergarten kids or first graders, every time there's a storm, you know what they do? They go, ah, and they go run hide under the bed. No, they're good. They're just fantastic. So let me explain how this whole thing works, okay? So, and I love this photograph. This is a photograph. I want to say this was taken back in the 80s. This is in Marengo County, Alabama by Johnny Autry. Mr. Autry actually sent me a framed copy of that. And understand, back in the 80s, there were no cell phones, no digital. This is film. That was hard getting that shot. That's an amazing shot. But here's the way it works. Where you see that flash. In that flash, in about 1 second, lightning heats up instantly to about 50,000 degrees Fahrenheit. That's hotter than the surface of the sun. That's hot. 1 second. What happens to air when it heats up to 50,000 degrees in 1 second? Now, that would be a fun science experiment right there, but don't do that at home. If you did that experiment at home, guess what you'd do? You'd blow your house up and burn it down. So I would not advise doing that. But when air heats up to 50,000 degrees in a second, it basically expands so rapidly that it explodes. There is a massive expansion of air. We call that what? Thunder. So when you hear thunder, that's when you go inside, even if it's not raining. So what's the rule? 8 miles. If there's lightning within 8 miles outside, you stop whatever you're doing and you go inside. Listen, college football games, 100,000 people are there. The games have been stopped. The players go in the locker room. The fans are told to go on the concourse. That's the right thing to do. It doesn't matter what's going on. You've got to stop because lightning is so close that you could be hurt. You don't want to be hit by lightning. That's just not a good thing. And if you're outside when there's thunder, you know what I'll do? You just might win something from me. If you stay outside when you hear thunder You just might win the Bonehead Award. And you don't want to win that from me, okay? You don't want to be a James Spann bonehead guy on television by staying outside. And I love this photograph. This is why there's an 8-mile rule. This is taken down over Tampa Bay. Under the Cumulonimbus, you can see it's raining. But wait a minute, where's the lightning striking? The lightning striking is where? Away from the rain. Yeah, lightning can get out of ahead of a storm by 5, 6, 7, 8 miles. And so when you hear thunder, even if it's not raining, get in. Now, here's a case where, yeah, it is pouring. And what in the world is falling down there in that grass? Does anybody know? Not snow, but hail. Every once in a while, storms can do that. Now, most storms don't, but from time to time, storms can drop little balls of ice, and we call that hail. This is what hail looks like. And again, you're not going to see this a lot. But if we ever see large hail, there is a word for the storm. The word is called severe. So this is for all the adults watching. Everybody in here, you should know this. A severe storm, okay? When a storm is severe, only 2 things can make it severe. One of 2 things. Number 1 is hail. How big? 1 inch in diameter. That's about the size of a quarter. The only other way a storm can be severe, it's high wind. Here's my next question. How many miles per hour must the wind be blowing for a storm to be severe? The right answer is 58. 58 miles an hour. That's what makes a storm severe. On this date 2 years ago, we had some big hail in my state. This was 2 years ago today. And by the way, that object in the middle, that is not hail, that is a Mountain Dew can. And we actually like for people to do that. If you put an object of known entity in there, then we know how large the hail is, okay? But that's way more than 1 inch in diameter. In fact, we had the largest hail on record in the state of Alabama that night up in Cullman, and this was bad. This was not good. Cars, windshields were shattered, dents in the cars. You had so many roofs of businesses and homes that were severely damaged. It was a very rough night. In fact, anybody know what kind of ball that is right there? That ball by the hailstone, that is a softball. That's softball-sized hail. All right, but listen, I got to do something now. I've got to teach you guys some storm spotting. Before we finish all this, I've got to teach you guys some storm spotting. A lot of people want to help us, and when they see a cloud they think is kind of scary or severe, they'll get on the tweeter or the Facebag or something. They'll say, hey, there's a mean-looking cloud out here. Well, what does that mean? I expect to see a frowny face on a cloud. So let me throw up a picture, and let's see if you know what this is, okay? Does anybody know what that is? Now, a lot of people are going to see that, and guess what they're going to do? They're going to report, I've got a tornado out here. Well, no, you don't. Look down there underneath that creepy cloud there. There's no tornado. There's nothing happening. If there was a tornado, debris and stuff would be flying everywhere. There's no tornado. This is the back of a severe storm, not the front, but the back. And this feature is called a wall cloud. That's a wall cloud, okay? Now, here's the deal with wall clouds. By themselves, they're not dangerous. They are not dangerous. But here's the deal. This is where tornadoes come from, okay? This is where tornadoes come from. And if we get a good report of a wall cloud, often a more timely warning can be issued. And again, this is not the front of a storm. This is the back. Let me show you guys the front. Here's the front of a storm. We call that a CLC. Anybody know what that is? CLC. Creepy looking cloud. Now, that's a shelf cloud. Those are pretty harmless, and they do look kind of scary, but it's really no big deal. Most strong storms have these on the leading edge. In fact, that's a shelf cloud coming over Birmingham. I can see the Sloss furnace down below that. But that has nothing to do with a wall cloud, nothing to do with a tornado. I want to know what's happening on the back of the storm, because sometimes on the back, you might see something like that. And again, so many people are going to report that as a tornado. And if you look really carefully down at the ground level, there's nothing going on down there. There's no debris. That is not a tornado. That is a wall cloud. And you see those spiral bands, kind of like when you twist Play-Doh, those are striations. And that means that wall cloud is slowly rotating, not like a tornado, but that's a rotating wall cloud. And here's the deal. We need to know about wall clouds because sometimes out of a wall cloud, you'll get this. Does anybody know what this is? That's a tornado. You got that right because now you can see the dirt and the debris down there at the bottom of the tornado. That is clearly a tornado. Now, storms are good. Tornadoes are bad. But wait a minute. Wait. There is one good thing about a tornado. Guess what that is? They don't happen a lot. Okay? They don't. Hey, you might live to be as old as me, and I am as old as dirt. And you will never, ever see one, okay? Never be afraid of tornadoes. Never be afraid of weather. Tornadoes rarely ever happen. But if they do, all you have to do is know what to do. It's like a fire. I'm not afraid of a fire. If there's a fire, you stop, drop, and roll, okay? All you have to do is just know what to do in case there's a tornado. Let me show you a tornado video here. This is one from our friends at Severe Studios. This is Corey Hartman, and again, they've got a great website with some amazing video. A tornado coming across a farm, and you're going to see some of the buildings, sheds, and a barn being taken up. Remember, tornadoes are air that's going up. But this is the most important thing we do. I mean, come on. If that thing was around my house, I would really want to know. I mean, come on. Nobody should be driving down that road. It's going to take out the trees, the fence, the power poles. That's not a good situation. And that's not really a big tornado. That's a smaller one. But that's what we do. Now, let's go back 9 years ago. We had a really bad day in my state of Alabama 9 years ago. This year, next month, on April 27th, 2011, guess how many we had in one day? 62. How about that? 62 tornadoes in one day. That's pretty remarkable. This is a map of all of them. By the way, all tornadoes get a number. That scale, you see the EF rating. That means enhanced Fujita. The weakest tornado is an EF 0. The biggest is an EF 5. Hardly any of them are 5s. Most all tornadoes are EF 0s and EF 1s, but those are important, and you need to pay attention to all of them. Let me show you guys one of these. We had 3 5s, by the way, that day. The purple lines, 2 of them were side by side in northwest Alabama. 1 was in northeast Alabama. Let me show you guys number 37. This hit a town called Cullman. Okay, this is a really bad situation. About 25,000 people live here, and this is going to become an EF4. By the way, the creeper there, that would be me. All I'm doing is standing in front of a green wall at the TV station. It looks like that's behind me, but that's the way weather people work on television. But let me tell you why this is a good story. There was a very good warning, and people knew how to get the warning. The message we use when there's a tornado down, it's called the tornado warning. People knew how to get the message. They turned on the TV, and there it is. They didn't have to look out the window, walk out in the front yard, and they knew where to go, and they got there. Everybody was fine. Now, was there bad damage? Yes. But listen, we can rebuild a house, a church, a business, anything. We just have to be sure that you're okay. And again, this is going to be an EF4. Let me show you one of our 5s this day. This is an EF5. This thing is so large, it doesn't even look like a tornado. That's a large wedge EF5 tornado on April 27, 2011. But there was plenty of warning. That's the good thing. We could see it on radar. Look for the hook and the debris ball on that storm. It was very easy to warn people on this day because the signatures were so amazing. This came through a town called Hackleburg and a town called Phil Campbell. We flew our chopper over these sites the next day. And remember, this is an EF5. This is Hackleburg. Hardly any tornadoes are this bad. But as bad as it looks, most people were okay there. Now, this is coming up to a town called Tuscaloosa. This is later that day. There's the hook and the debris ball on radar. And this is a camera we have on top of the Tuscaloosa County Courthouse. And this is an EF4. This is a pretty rough situation here. Coming through the southern part of the city of Tuscaloosa, coming through a neighborhood called Rosedale Courts at that point. And this was pretty bad. But again, people had 45 minutes to go to a safe place. And again, this is on top of a building. We had people down on the ground. This is coming from John Brown and Mike Wilhelm. John's video is pretty remarkable. Now, many tornadoes you can't see. Let me just remind you of that. You can't see most tornadoes. Many of them don't happen during the day. They happen when? At night, okay? Many tornadoes you can't see because of hills and trees if you're in the southeast United States. And often they're just totally wrapped in rain. But you could see that one on that day. And again, John is a trained spotter. Don't you dare do this. Go out there and try and get some YouTube video of a tornado. Don't do that unless you've been trained. for years. John has been trained for years and years and years. He's one of the best in the business. That's moving away from him. He's perfectly safe. Here's the same tornado, and this is scary. Look at all these cars. They have no business being out there. And thankfully, this guy saw it, and he backed up, and he put his car in reverse. If he would have kept on going, that would have been very bad. Now, by the time that same tornado got to Birmingham, you can't see it. It's all wrapped in rain. Same tornado coming through Pleasant Grove and Pratt City, all wrapped in rain. About the only thing you can see are lightning strokes in there from time to time. But that's what it looked like from the City Federal Building. But let's talk about safety real quick, okay? A tornado is coming. Where do you go? Not a big room, but a small room. I took most all of these images. This man was fine in this house. The roof is gone. The walls are gone. He was in the hall. We want you in a hall, closet, or bathroom. If you go into those places, you're going to be snug as a bug on a rug. You are going to be just fine. Small room. Everybody's got one, and not the highest floor, but the lowest floor. Here's a business. They were in that hall, and they're just fine. And let me just say one thing. If you live in a trailer, a mobile home, you have to leave, and you've got to talk with your parents about where you go if we ever have a tornado warning. Never be afraid of this, but you need to have a plan in case it ever happens. The biggest problem we had on this day, people thought they were going to hear a siren. No, you won't. Oh, you might hear one on a sunny day at 3 in the afternoon. Can you hear one at 4 in the morning during a raging storm? The answer is no. We know that that was a big problem in Nashville a couple of weeks ago. People thinking they're going to hear a siren. Sirens are a product of World War I. Goodness, we have to move past that. Every house has to have one of these, and I hope you do. Do you know what that is? That is a weather radio. And what's really bad, most homes don't have one. So this is your homework. You got some time to do this now. Go get one, especially if you live in a tornado-prone area. They're not that expensive. It sounds a loud, and I mean loud alarm in your house. This will wake your family up. You know to go to your safe place. If the TV's turned off, you'll know it's happening. Every home, every business needs one. So those are tornadoes. Real quick, we got to move along here. I'm taking too much time. I love talking about weather. That's no tornado. What's that? What is that? That is you got it, hurricane. Hurricanes are big. Tornadoes are small. Hurricanes are born over the ocean. This is one over the Gulf of Mexico 2 years ago. Hurricanes get names. They can stay out there for weeks. This is called Hurricane Michael, coming up on Panama City Beach, Mexico Beach, Port St. Joe, Cape San Blas. And the water's got to be warm. We don't have hurricanes in March. The water's too cold. The hurricane season is June 1st through the end of November. Most of the really big ones come in July, August, and September. That's when the water is really warm. Here's one from last year. Anybody remember this hurricane? This is called Hurricane Dorian. That little island nation that's east of Florida, that's the Bahamas. And that was a really, really rough storm because it just sat there for hours and hours and hours, not moving. This is the eye of Dorian. You could basically look right down into the Atlantic. But some of the heroes that work in our science, the United States Air Force, they fly these C-130s right into hurricanes. They're called hurricane hunters, and they don't fly around them or over them. They fly right in there about 10,000 feet, and they'll take basically the same type of equipment we put up on the balloons, and they'll drop them down that big tube, and they measure the pressure and the wind, and they do a great job. This is an amazing photograph they took last year in Dorian. This is the eye of Hurricane Dorian, a raging hurricane. But you look up in the middle of that big storm, you see blue sky and sunshine. That's absolutely remarkable. But again, so these happen mainly in summer and early fall. But remember, my favorite season is what? Yeah, winter. This is probably my favorite snow here the last 10 years. This is December 8th of 2017. This was a good one. They played a state high school championship football game that day, and plenty of good seats were available. That was Bryant-Denny Stadium in Tuscaloosa, but the roads weren't that bad. They were just wet. People had power. We knew this was coming. People were home. It didn't last long. And remember, this was December the 8th, which means this was before Christmas, so many people had Christmas lights up. And that was just awesome. So this was a really good snow, but sometimes we don't have good snow. Sometimes we have what? Yeah, bad snow. Oh, boy. This was that horrible Snowmageddon of 2014. I mean, this is just not good. We thought it was going to snow a little bit, and that basically was right. It snowed a little bit, but we didn't think the roads would be that bad, and man, we were wrong. Oh, boy. Here's what happened for Snowmageddon back in 2014. As the snow came down, it melted. And understand, this is only 1 to 2 inches of snow. This is not much. But as the snow came down, the snow melted. The ground was warm. But the air was so cold. The air was 18 degrees Fahrenheit. The snow melt turned into ice. And those roads were covered like we had a crippling ice storm. And we've not had any experience with something like that in all my years of a flash freeze. And everybody left at once, and people got stranded. They were down there for hours and hours and hours. Some people running out of gas, getting cold, hungry. They're down there burning fires on the side of the road just to stay warm. And this is a big mess, and guess what? We caused it because of the lack of understanding of ice accretion on roads. So this is a reminder. There's a lot of things we don't know. There's a lot of things we can't do. I need some of you to get into our science, the science of meteorology, and help us, okay? There is so much we have to learn. And I promise by the time you guys get to college, there will be a lot to learn. All right, I'm not done yet. We're almost, I gotta give a shout out here. These are some of my social media accounts. If you're watching on Facebook, you know my Facebook feed. On the Twitter, I'm just Spann, my last name. On the Gram, Spann WX. But a big shout out to all the kids that are watching today. I mean, we've got thousands and thousands and thousands. That's a good-looking guy right there. I like his wardrobe choice. I have no idea why. But this is the one thing that I do miss, but it's great to be with you guys virtually online today. And before you know it, life's going to be back to normal, I promise. I'm an old guy. I've been through a lot of crazy, scary times in my life, and everything is going to be just fine. But again, thanks to everybody for sharing these images, and I wish I could show all of them. We'd be here until midnight if I did that. By the way, I like that choice of reading right there. She's got my book. I wrote a book called Weathering Life. If you're interested more about me and my life story and the science and the events I've covered over the years, go to spannbook.com, 2 N's, spannbook.com. It's a great read. There's an audio version on audible.com as well. How's that for a quick personal plug there? But again, for all the parents, thanks for giving us an hour today, and we'll try and do another one of these soon, maybe even this year while this little outage is going on here. But again, the kids, and I've seen so many states, and I've seen a lot of countries represented here in the comments section today. So thanks to all of you guys. And a special shout out. This guy's name is Kaysen. Lives in Charleston, South Carolina, and I happen to be his Gampy. Yeah. I was showing him my steal sign as a baseball coach. 2 fingers down, you steal. But Kaysen, we're proud of you, and we love you from Gammy and Gampy. So thanks for taking the time to watch today up in Charleston. So that's going to wrap this thing up. Thank you, guys. We're going to wrap it up just under 1 hour, a little longer than I thought, but I love to talk weather. So again, if you have any questions about anything we've talked about today, you've got my contact information there. And again, we'll see if we can do another one of these fairly soon. Thank you guys for watching. Y'all have a marvelous day. Go outside and breathe some fresh air. Look up in the sky. You'll see things that are amazing. Thank you guys for watching. Bye-bye.